Okay, I'm going to go over the 10.2 quick check kind of quickly. Okay, it says to draw each of these shapes. Okay, write in the name of the shape and the bond angles. Okay, so for steric number 4, I like to draw it like this. And I put a little bit out like that, a little bit different than the way Mr. Koo does it. Okay, if I had a lone pair, though, I'm going to draw my lone pair like this. And then the other 3 will be the same. It's kind of like a spider. Okay, and then my last one here, I'm going to draw 2 of these, and then the other 2 lone pairs, I'll do one here and one here like this. Okay, so if I put my atoms in, here's an atom, here's an atom, here's an atom, here's an atom, and here's an atom. Okay, so that shape is tetrahedral. I'm just going to write tetra, and my bond angle is 109.5 degrees. Okay, for here, the second one, okay, these are going to be a little bit closer, about 107 degrees, okay, and this is called trigonal pyramidal. Shortening everything, so a little triangle for trigonal and pyramidal, like a little flat pyramid. Okay, when I have 2 lone pairs, this guy is bent. And lone pairs tend to repel more than bonding pairs, so it'll be about 105 degrees. Now for these pictures here, steric number 3, 1, 2, 3, okay, and everybody here is about 120 degrees. And again, the atoms would be, right here and here and here and here, like BH3 or something like that. Okay, if I were doing one lone pair, then I would make that lone pair, let's say, going up like this. Okay, I'll make it a different color, so make that lone pair like that. Okay, so what I have left here, this guy looks bent. I would still say it's 120 degrees though. Okay, that lone pair doesn't push that much. And the last one here, if I'm going to do, let's say, one straight across this way and one straight across this way, okay, so I'd say my bond angle is now about 180 degrees, and I would call this linear. Okay, so it's really terrible writing, sorry about that. Okay, down here, these compounds. Okay, the compounds, depending, you have to like draw them first. I'm going to go ahead and draw them way off to the side here where I have a little bit more room. So CH2, C like this. Okay, then I can make a H off this way, another H off this way, Cl, Cl. Okay, where I could do it with dots. PCl3, phosphorus. Okay, hook on a chlorine, hook on a chlorine, hook on a chlorine, lone pair on my central atom. Okay, put all my other lone pairs in. And I forgot my lone pairs on my other picture. Okay, O3, O looks like this. Okay, it goes a single bond, double bond, 2 lone pairs here, 3 lone pairs on this guy, and that's going to be resonance. So I'd have another oxygen with a single bond to the right, and a double bond this way. SF2, okay, sulfur, it has 2 and 2 and 1 and 1, so it can make a bond to to a fluorine, and another bond to the fluorine, lone pairs. And BH3, boron, okay, can make a bond this way, bond this way, bond this way. Clean that up a little bit. And BeBr2, okay, we're going to pretend that that is a covalent bond, okay, because beryllium family 2, doesn't do octet rule, so it looks something like this. Although if I found out that beryllium bromide actually is ionic, that would be okay too. Okay, so those are our Lewis structures. Now I'm going to go back and say, well, what's the shape? Well, on this first one, CH2Cl2, you can see I have 1, 2, 3, 4 bonded atoms, no lone pairs, so my steric number is 4. For PCl3, I have 1, 2, 3 bonded atoms, 1 lone pair, so my steric number is 4. For this oxygen, I have 1, 2 bonded atoms, 1 lone pair, so the steric number is 3. Okay, for SF2, I have 2 bonded atoms, 2 lone pairs, so my steric number is 4. For BH3, I have 3 bonded atoms, no lone pairs, so the steric number is 3. And for BeBr2, my steric number is 2, 2 bonded atoms, no lone pairs on the beryllium. So those will help me with the shapes. So if I have this first one up here, so I say 1, 2, 3, 4, it looks tetrahedral, because there's no lone pairs. And polar, yes, it would definitely be polar, because I have chlorine and chlorine, which are different than the hydrogen. So one of my, this side here would be a little bit negative, the other side would be a little bit positive. For PCl3, okay, it's going to be tetrahedral as far as the electrons, but since there's no atom on the one side, then what the shape is going to be, it's going to be like this guy here. So it's going to be pyramidal. And again, it's going to, yes, it's going to be polar, because again, if I do these as vectors, I would see that all of my vectors are pointing down toward chlorine, so there's going to be a downward polarity. So it's going to be a little bit negative on the chlorine side, positive on the phosphorus side. O3, this one I find a little confusing, because if I look at it, one end's, they're all oxygens, so they should be kind of nonpolar, but I think it really is polar. So we would stay away from this kind of a question on a test. But for the fact they're all oxygens, I think I would guess nonpolar, but I do think it's a polar molecule. The shape easily just bent. SF2, this is definitely bent, and will also be very polar. Okay, so the fluorine side would be negative, and the sulfur side would be positive. Okay, BH3, we have 1, 2, 3. Those are all going to be at 120 degrees, so it's going to be trigonal planar. And I would say that that is nonpolar. And BeBr2, that's going to be linear and also nonpolar, because even if these do have vectors, they would cancel each other out. And that is quick check number 2.